Welcome to episode 3 of Magic Carpet's restoration.
In case you're new here, I bought Magic Carpet a Vinda 32 4 years ago. When I bought her, she was a total shipwreck. She had fallen 20 feet from a crane onto concrete. The stern completely blew off, there was a huge crack in the side, the keel was damaged, and the rudder was crushed. At the time, I had just begun a 3-year boat building apprenticeship in Switzerland, so in my spare time, I worked on restoring Magic Carpet. 4 years later, she's now finally finished and sailing around the Mediterranean. During the restoration itself, I didn't take any footage, but this mini-series from the Sailing Magic Carpet channel is about the thought processes, theories and techniques that I went through to repair Magic Carpet. This particular video, episode 3, is about the basic principles of doing a fiberglass repair. I made this video for people who are totally new to the world of fiberglass repairs and who want to get an idea of how they work.
I'm going to start by showing you the brief process on how to approach a repair. So this is what you start with. Obviously, inspecting the damage. To inspect the damage, you have to get good access of the damaged area. Are there things installed in the boat? Is there maybe something behind it that I don't see? All of that is part of the inspection. Take a scraper. In my case, the damage was so severe that I don't care about details. Like, if I have to drill another hole or two next to it, it wouldn't change much. If it's a small damage, there might be other tricks, like just by knocking on it, how does it sound? Is there some kind of delamination? You don't want to drill a hole to make sure. But in my case, even take the grinder, take some material off with a hammer, like really get to know what's behind. Many times with fiberglass, with composite, there is many hidden damages. It might only be a dent on the surface, but it might reach further than that. So check the extent and degree of the damage. Step 2, remove damaged material. Step 3, preparation of the repair. This is a very important step, which I will dive into further in a bit. Afterwards, complete the repair. Inspect the repair quality. Is there any delamination, inclusions? Did dust go inside, or even air bubbles, which you would not want? And also you check it for proper cure. Was the temperature good? Was it too moist maybe? Was it too cold? Did you get the wrong ratio of hardener and epoxy, or polyester and hardener? Whatever the case. Inspection afterwards is just as important. And step 6 is restoring the surface finish. I plan on making an entire episode just about the surface and the finish, because it includes completely different materials, different tools, but this time let's focus on the rough part of the repair. So let's dive further into the extent and degree of the damage. So I have labeled 3 types of damages here. There is the low energy impact, medium energy impact, and high impact. The low energy impact can easily cause hidden damage. So here displayed we have the layers of fiberglass, and in case of a crack, you might just see a little crack on the surface. But forces, they tend to travel easily through fiberglass, so it might create this pyramid pattern from just this one crack. So low energy impacts, they can easily cause hidden damages, since all this is hidden to the eye and you only see that one crack. So inspection, hammering, sanding a bit. Once you get gel coat and paint off from the surface, you can easily tell if the fiberglass has suffered any damage, if it's not impregnated properly, if it has delaminated, or if there is those other cracks. Since fiberglass, depending on what resin you used, it might be kind of yellowish, and instead when it cracked and there is air and delamination in between, it turns white. So you can tell pretty easily upon that. A medium energy impact instead is visible to the eye from outside, since you have the area which is crushed. There is a dent, there is a crack, it bumped against something. And here as well, there is cracks inside the fiberglass that reach further than what the eye sees. Also, it is very possible that delamination occurs on the outside area of the crushing. Fiberglass on a finished boat consists of many layers of that woven fabric. So when you get an impact, those might not stick perfectly to each other anymore. They don't have a perfect bonding anymore, so that's what we refer to as delamination. Then there is the high energy impact. That's, I think, the case on Magic Carpet. It was all just broken. There is cracks, the fibers are broken, it's through the hole from side to side, delamination, just everything nasty you can think of occurs in that case. Removing the damaged material, that can be very different depending on the example, on what you have in front of you. In my case, it was a total complete shipwreck, so I went at it with very rough tools, angle grinder specifically, even the hammer and chisels, just to get rid of everything that was broken. Now let's switch to step 3, the preparation of the repair area. Once you have removed all the damaged material, it is very important to prepare that repair area. One thing is scarfing. That means depending on the thickness of the fiberglass, you will have to taper the area you repair. There is different methods to approach this. One very important thing is you always want to tend to oval shapes when making a repair. If there is any angle or anything square, you have to round it off. Another part of the theory is anything diagonal creates a much bigger surface. For the best repair, you would want to give it the biggest surface possible. So that's why, depending on the extent of the impact, you change the ratio of the scarf you make. Let's say there is a small damage, then it tolerates a smaller or steeper scarf. Like here, in just an example, if the thickness of the hole is 1 centimeter, then you do the diagonal line 20 centimeters. And instead, if it is a big damage, then get the strength back. You give it a scarf of 50 or even up to 100. There is also the approach of doing a single-sided repair. That means maybe it's just accessible from one side, or there's various reasons why to choose that. In most of the cases, I did a double-sided repair, or more on one side and less on the other, but mostly from both sides. That is just my preference. If it is accessible, and in my case I made every repair accessible, then it just sounds better to me. And when you do a double-sided repair, the scarf actually can be a bit less since you do it on both sides. I'm sorry, it's a bit a mess. I hope you understand what I mean. So these were the tools required for the very first approach, examination of the damage. Not always, but after a while of itching and fiberglass in the underwear, I discovered that this onesies, the suits by 3M, they are very handy. Also, when you work with the resins afterwards, so they keep your jeans and everything from being sticky. Gloves, these are for when I'm using the heavy duty tools to protect my ears, glasses, a mask. This one should be symbolic for the vacuum. And then very rough tools, in my case, for getting rid of all of the crushed fiberglass. So here I have chisels and a hammer. We use chisels for woodworking, and those we have to keep in excellent shape. So I have another set for banging on fiberglass and just doing all of the other things that you can do with it. So make sure it's not the nicest set that you use. And also I was using more the bigger ones, which I use less for woodworking. Scraper, there are many kinds, but this one is quite useful when you want to get rid of the paint or get rid of the gel coat, see how it looks underneath. So this is also a good tool. Drill, I could not imagine working without a drill. That's just a multi-tool for many things. Scissors, I have tapes. On Magic Carpet, I didn't use any of these because it was a total shipwreck. So you can imagine I didn't have to protect anything. I just decided to do pretty much everything again. But if your boat half is nice still, try to protect that nice half by using some tape, cover things. Then this was a much used tool, the angle grinder. You have different grit sandpapers for it. I was mostly using 24 and 36, which is almost one of the roughest one. What I liked here was learning on how to use it with one hand and hold the vacuum on the other hand, since it rotates clockwise and then the sand dust always goes in one direction, but depending on how you move the angle grinder, it goes somewhere else. So after having my face full of this a few times, I learned on how to use it simultaneously. Very important tool, the angle grinder. You can also change the sandpaper and give it a blade for cutting. Sometimes I just decided to cut sections off, and I did this or with the angle grinder or also with the jigsaw. So not necessary, but also useful. The jigsaw, you can just by this blade remove complete sections of it. But I mostly use jigsaws for wood, plywood. Make sure to use something specific for fiberglass, since otherwise, depending on the thickness of the hole, thickness of the material, they don't last at all. There is some specific ones though for fiberglass. And then another important tool, something to sand. So this is a machine that I use very often. I use it before the repair to prepare the area, to do the scarf. Also, once I have laminated, to make it a bit smoother again. Very handy tool. And I thought I'd show you these two too. They were more specific to my repair. So I don't know what to call this. Maybe somebody can help us out. But basically it can be wooden. It just has to be perfectly flat and clean. So basically what I use this for is to get the hole back to its perfect shape. Let me display it. By holding this to the hole at one point, and then also on the other side I get to see if there is air in between, how much is affected of the area, is it still bending inwards, does it pop out. This is very important to get the general overview. And then I move it up and I see it's perfectly smooth, it's laying on the surface everywhere. Further up again. So this is more of a tool that I use when the repair is done also, to recreate a perfect finish just before applying paint, since once there is fresh shiny paint on a hole you see every imperfection. Very handy, very simple tool. Also, when applying the layers of fiberglass, I check the surface every time I apply new layers of fiberglass to see how much is missing to get the perfect curve again, or do I already have enough on it? And also you can determine exactly where you have to sand. So I would start at the bottom or the top and then move up little by little, take my Sharpie and draw lines on the sections. There you have to do it how you please, or you mark the sections where material is missing, or you mark the sections where you already have enough. So I love this. This was another simple, helpful tool, pretty much to determine how the boat is sitting on the trailer. Is everything even? Isn't it in the middle? I want to show you another tool which I used for the repair. It's not crucial, but since we have one in the boatyard, it made it very handy, but I hate it. So you can all be glad not to have one. It's very expensive, and basically it's a gel plane. I hate this machine, but it was so handy. So basically it's an electric plane which runs at about 3,600 RPM. This diameter of hose is not enough to get all the fiberglass into the vacuum while the machine is running. It's an absolutely hideous thing, but you can get layers of 1 millimeter at the time away. So my hole was about 2 centimeters thick, so imagine I would sand it, or, well, chisel also worked quite well. But once you have to have something more accurate, the gel plane, the electric plane, seem to be very handy. I use this on almost every surface, and that works like this. Once it's running, you attach it to the hole, and then you have to move down. You switch over just a tiny bit, and then you continue. So this tool is mostly used for osmosis repair. That's when the hole gets those nasty blisters, which all boat owners might have heard about. So this is the osmosis plane to get rid of the gel coat, get rid of the affected layers of fiberglass before you start applying the new ones. Hideous machine. Glad we have it. So after showing you some of the important tools, let's move over to fiberglass. What is fiberglass? Basically, it's made from two components. One is the structural one, which is the fibers. There are many different fibers. There are glass fibers, Kevlar, carbon fibers, but those wouldn't be anything not combined with the resin. So it's always the combination of fibers and resin. There is different kinds of resins, polyester, epoxy, there is more, but let's start with the fibers. I have a few options displayed here. This one is the very basic glass strand mat. It's glass filaments just randomly laid to create a cloth, and they are held together with the binder. So I'm not sure about this, there might be different binders, but what I have learned is do not use this in combination with epoxy. Epoxy doesn't like the binder that is used to hold this mat together, so this is only used with polyester. This is very easy to use, it's the cheapest, and it exists in various thickness. Thickness can change. So you speak of it as how heavy the square meter is. This one is something like 200 grams. Then there is 450, there is various options. Also, I want to show you this one. I did not need it in my repair, but this is the thinnest one that exists. And it's basically used when you have a mold, when you use a mold to create something, even a complete hull of a boat. When it's in the mold, you first start with a layer of gel coat, like you see on this boat just behind me. The first thing you put in the mold is gel coat. And after the gel coat, you start with one of these thin layers. Basically, this is, if you would start with the strand mat, you have many fibers which could puncture the gel coat, which could, after a while, since polyester shrinks, you could also see the fabric. So this is a little bit to get a smoother finish to protect the gel coat. It's just used with molds, as far as I know. I thought I'd show it to you since we have it. I did not need this for Magic Carpet. Basically, what I bought for Magic Carpet was strand mat, since my philosophy is repair it with what it's made with. A lot of strand mat. There is many more high-tech solutions nowadays, but those holes are 1 to 2 inches thick and it does the job well if laminated well. Afterwards, there is the woven fabrics. They also come in different shapes and sizes. This is a very thin one. You can bend it around edges. It's very smooth, it's very nice to work with. This one I use for small repairs, something around an edge. If you want to cover something made out of wood with fiberglass, you use the thinnest cloth possible. Then we go up a step. Here I have an example of something a bit thicker. And then there is what I know as the roving. Roving is a lot thicker, and basically the first things that I bought for repairing Magic Carpet was a lot of resin, polyester resin. I'll get to that later, why I chose polyester resin and not epoxy or something else. And together with that, I bought 2 rolls of strand mat, one thicker and one thinner, and I bought 1 or 2 rolls of roving. You can see it here. The one I bought is a pretty thick version, because also here I decided apply again what it was made with. So I saw a bunch of roving in the construction of Magic Carpet, so I decided to do it the same again. Any of the further materials were not used for my repair, but I thought I'd give you a brief introduction since we have some of them here. Very famous are the carbon fibers. So basically we switch now from very thin glass filaments, we switch to carbon fiber filaments, and also here they can just be unidirectional on a roll like this, or they can be all layered into a cloth. And this also exists in various configurations depending on what you're working with. Is it for a pole? Is it for a mast? Is it for a hull? Here we have layers going this way, layers going this way. This one instead is unidirectional, and they also exist in various thickness. Keep in mind, carbon fiber always used in combination with epoxy now. Strand mat only with polyester, carbon fiber only with epoxy, since we are moving up to more high-tech materials. Another one is Kevlar. It has its very distinguishable yellow fibers. This is extremely tough on impact, which carbon fiber is not. It might break easily on impact, but it's incredible because you can get lightweight things incredibly strong. But if it is impact, for example, a reinforcement on the bow or anything like that, Kevlar will do. It's more difficult to work with. It's very hard to impregnate the fibers. But yeah, here it is. One very precious other thing is peel ply. Peel ply basically replaces sanding, because when you work with epoxy, once it's dry, you have to sand the surface to get good adhesion again. But if you put a layer of peel ply on top of what you've worked with, then you can rip that cloth away again. Then you have a rough surface right away, and it doesn't require sanding. Often it still does a bit here and there, but this is tremendously helpful. I didn't know this at the beginning. I didn't need it for Magic Carpet since I didn't use epoxy, but peel ply, it's worth it. When I worked for the catamaran for 6 months, we use only epoxy, a lot of it, huge surfaces, all laminated, and peel ply made it so much easier because it still requires a lot of sanding. Here I have two arrangements which are used when you use vacuum. You might have heard that for building a boat, often, and especially nowadays, more and more, you don't do the wet layup by hand, but you use vacuum. So when you use vacuum, basically after you have, let me use this one. Let's say we are using carbon fiber. We're using carbon fiber in our mold. It's impregnated with epoxy. What I do afterwards is put the peel ply on it. After the peel ply comes a thin layer of plastic, and if you watch really carefully and closely, it has tiny little holes all over on the surface. Those are important since without it you could not create a vacuum and it could not get rid of the excessive rosin. And after that we apply, I don't know what it's called, a cloth. This one is basically to get rid of all the epoxy which is not needed. To get a better weight to strength ratio, it's best only to impregnate the fibers, but any excessive epoxy have to get out somehow. That's why vacuum is a great solution, and the rest gets absorbed by this cloth. So this one comes on top of that layer, and then at the end I have, this one represents the vacuum bag. So basically this one covers the whole thing that I'm working with, and it's sealed on the edges. Here I stick the nozzle of the vacuum and I can start sucking the air out. So this is just to show you a little bit of theory on how that would work. So here we can move further to application methods. After a while of using this, they told me, why don't you use the rollers? And I was like, well, thanks for that. That advice could have come a bit earlier. So these rollers, they exist in various sizes. Well, not in various shapes. Shapes is the same, but diameter can change, the length can change. These can be very, very useful since you can just mix your epoxy, pour it in one of these containers, and impregnate the fibers. So very handy. But a very common tool to use are brushes. Just impregnate the fibers. And, one more important tool. Here is 2 rollers. They are made out of aluminum, plastic. They look pretty shitty after a while if you don't take great care and wash them properly. So basically this is, once you have impregnated the fibers with your resin, you want to get rid of every little tiny air bubble there is in the fabric. Let's say we have this cloth here. We have impregnated it first, and then we go over it with our rollers until we have squeezed all the air out of it. Oh. So the rollers are also very important. These ones I use for coves. What is a cove? Let's say this is a bulkhead or anything in the boat. I want to fiberglass it onto the hull. So this is standing vertically. I have a 90-degree angle, and it is not ideal to put fiberglass in a 90-degree angle. First of all, it's not as strong as it could be. It can be very difficult to get all the air out. So basically, how do we solve this? Always give it a cove. So that means you mix epoxy or your resin with some fillers to make it thicker, let's say like peanut butter, and then you spread it on the seam, and then with one of those I can give it a radius. So that is our cove. Let's give it a smooth cove here, and then I can put my cloths of fiberglass over it so they run smooth and have the best connection and best strength. Here is the 2 most common boat building resins that I want to introduce to you. One is epoxy and the other one is polyester. So I thought I'd make a quick comparison, pros and cons. Polyester is the most common choice. It is easy to use. It's not that expensive. But you have quick working times, which are accelerated the hotter it is. So that's a bit of a drawback. It also shrinks. The more things you add to it, additives, the more it shrinks also. That's to keep in mind. And it emits a very strong smell, so I highly recommend using a mask or respirator when you use polyester. So that's one thing that makes it a little less fun. There is different kinds of polyester. I just dive quickly into the 2 most common ones. One is orthophthalic, the other one is isophthalic. I'm sorry if I'm saying it wrong. I just know the terms from German. Basically, the isophthalic one has a superior water resistance, and the orthophthalic is just a standard economic resin. I used only the superior water resistance one. It's a bit more expensive, but I had many repairs below the water line, so where it makes sense to have something more water resistant. And then instead to epoxy, there is different types of epoxy. There is epoxies which are more liquid right away. There is epoxies which are denser. So it depends what you want to do. You want to work with vacuum, then you want to have something that goes everywhere, that is very liquid. Do you use it for bonding, gluing, then you want something else. And also on epoxies you have different hardeners. That is quite handy. So for example, in summer you take a slow hardener, so that gives you more time to work with. Instead, in winter you use a quick hardener, so it activates and hardens quicker. One method to accelerate the cure is heat. That works with both. So especially when it's cold in winter, like right now, I always cover the piece I'm working with plastic, and then I put a heater next to it. That is very important for a good cure. Yeah, so that was a very brief introduction. into the 2 resins. And me specifically on Magic Carpet, I used polyester resin. Why polyester resin? Why not go for high performance epoxy resin? First of all, when I started this project, I was earning $300 a month, so that was not enough to eat. So I went for the cheapest option, but also I didn't see any problems with that, since my philosophy is work with what it's made of. Magic Carpet is built out of polyester, strand mat and roving. So I grabbed those same materials to make it exactly the same again. I might have added a bit more of roving layers to make it a bit tougher even. In my opinion, there is absolutely nothing wrong with using polyester resin. Epoxy is way more high performance. You make something out of carbon fiber or with vacuum, it makes absolute sense to use it then. But for a boat which was built with polyester, it's totally fine. Even below the waterline, maybe if you can afford it, use the isophthalic one. It's not a big difference in price, but I thought it might be a lot better. But also you apply different layers of epoxy on the hole below the waterline anyway. So if you make a proper job with that, there shouldn't be any trouble at all with the polyester. I also want to mention acetone. You need this when you're preparing the repair. You want to get rid of all the contamination. You might use other similar liquids, other thinners. Acetone works for us. I use gloves since it is very aggressive. Your skin becomes very dry and, well, yeah, your brain cell absorb all of that. Paper, just some cloth. You always need a scale. Make sure to mix very accurately epoxy and polyester. Just do the best you can on both. One thing I've learned with experience, well, that was a quick one, but with polyester, always use glass or metal containers to mix it in. With epoxy instead, plastic cups are perfectly fine. The only thing is, the bigger the quantity that is left over in your cup when you're done working, the quicker it reacts. And it might get very, very hot, start bubbling and even cause a fire. So make sure you leave it outside to cool down before you throw it in the trash and something else starts burning. It has never happened, but I've seen some nasty smoke come out of my cups a few times. And instead, if you use a plastic cup for polyester, after just a few seconds that it starts reacting, it eats the plastic and all your resin will be on the table. So to mix it instead, also nothing fancy. Well, it is here, mahogany antique. We just use what we have. So to mix your resins, just some wooden sticks will do just fine. I also want to give you a very brief introduction into additives. So those are fillers. I show you the most common fillers. Basically, well, there is different types of fillers. There could be pigments, then it's to change the color. I don't have pigments here, but you can see on every boat, pigments are often used. I want to dive more into the fillers which you use to change the consistency of the resin. I am working overhead, for example. I don't want it to drip down, or I want to create one of the coves I mentioned before. You cannot do it when it's liquid, obviously. So here I have 3 displayed, which we typically use with epoxy. The most common one, especially in combination with woodworking, is cotton. This is pure cotton. Basically, think of the cotton fibers. Think of the cotton fibers as a snowflake when you put it under a microscope. So the more snowflakes you have together, it creates a stronger bonding. It's already like adding some of our structural fibers to it, so it's not just resin, which might be brittle or cracks when you whack at it with a hammer. So that is also adding a little bit of strength to it already. The two here are very common West system fillers. This one is 407. This one is 410. This one I used on Magic Carpet a lot. Actually, I wanted to show you the quantities that I had to buy in. They come in these containers. I have used one entire one when I was using epoxy for the putty for the surface finish, but I'll dive into this in the next episode. This one is quite easy to sand. That's why it was a good friend of mine. 4010 instead doesn't have many properties to it, but it is very easy to sand. I would not use it below the waterline too much. It's a very simple filler. Really handy just to fill out scratches, to make something even again, but I would not use a lot of it. I also have wood here. This is just sawdust. You can also add a little bit of sawdust, for example, when you're making a repair, a wooden repair. Make sure you always use epoxy with wood, not polyester, and to hide it a little bit, not to make it too visible. Also, epoxy turns yellow with UV light, which is one drawback of it. So if you use some sawdust, you can blend it in better to what you're working with. With polyester instead, I just have this filler. Basically, this is tiny little glass bubbles, and it does the same job again. I want to make a cove with polyester. How to change the consistency. The more of these bubbles you add, the more you change it from liquid to honey or peanut butter. So those are the very basic materials. I've explained a bit about the fibers. There's glass, carbon, the resins, some fillers. There is much more to it, and I'm still learning, but those are some of the basic things, and they are enough to restore Magic Carpet, almost, to restore the structural part of it. Here I want to show you some end results. One, for example, is core materials. This is basically when you do a sandwich. That is when you have a layer of fiberglass, some core material in between, and another layer of fiberglass. This is widely used for decks. Decks mostly are sandwich, and boats are being built like this more and more nowadays, since you can create something very stiff but a lot lighter than if it is just pure glass. Pure glass was the beginning, different thicknesses. And actually, let me show you. Here I still have a part of Magic Carpet's hull. So this was all hand-laid fiberglass. This is exactly how Magic Carpet's hull was made. And this is crazy. It's insane. Some hulls nowadays, they are a lot less than this and sandwich. So that means 2/3 of it is just core material, and then there is a little layer of fiberglass on each side. It's incredible. This one also belonged to Magic Carpet. I was not able to get the through holes away with any kind of tool or wrench, so I just cut it out with a jigsaw. And yeah, it's quite nice to see how it was and how it is again. Here I have an example of a very high performance boat. This was UBS Switzerland, one of the Whitbread racers which raced around the world. It's about a 20-meter boat. It's built with Nomex. That is some kind of, let's say, cardboard. Basically what they did here is a honeycomb made out of cardboard, and then It has a thin layer of Kevlar on the inside and a bit more on the outside. Isn't that crazy? That is the whole of the 1980s around the world racing sailboats. It's incredibly light, and I whacked it with a hammer as strong as I could, and I got this dent in it. So this is where technology is going nowadays. Well, this was already 30 years ago, so nowadays you use carbon fiber more often. You make honeycombs out of aluminum. There is all kinds of things. I have an example here. This is 1 millimeter carbon fiber on each side and a core, a foam core. So here's another example of some high-tech solutions. The deck in Magic Carpet is also sandwich, and one other core material is balsa. That is basically end grain of wood. I am very happy Magic Carpet was not balsa like the earlier models, but they already used foam in the deck. In case you have a leak, the wood, the balsa, tends to rot easily, so that can create a lot of problems. You might have heard of it. Foam is much better. It doesn't absorb moisture. It still is quite a pain in the polyester if you have to fix it, but foam is a lot better.